Hi, I'm Aditya, a final year software engineering student studying a major in data analytics. I personally have a passion for data and how information can be extracted from it and be used to better improve modern day life, efficiency, health, and much more. For over the past year, I have been working with my supervisor, Associate Professor Kwong Ha, and PhD student Hubert Nguyen to develop a data analytics solution for a low-cost environmental monitoring system, which is being researched here at UTS by the TULIP organization. Before diving into the specifics, I'll provide some context of the study. Air quality is becoming more and more important in our daily lives, as with more cars, construction, and natural events taking place, such as the bushfires in 2019, we need to become more aware of this invisible killer as a society. With almost 31% of Australians affected with a chronic respiratory condition in 2018 and growing concerns with climate change, managing our air quality is becoming increasingly important. With the advancement in technology, new methods are being developed to better track air quality in our urban communities. The technology that is being utilized in this study is low-cost wireless sensor networks, also known as LWSN. These systems utilize a growing part of the tech industry, which is IoT, Internet of Things, and is widely being used in smart cities. The way that this tech works is through an array of environmental monitoring systems, like the one we saw on the previous slide, being set up around urban areas to track environmental data. The records are then sent to a network server where it is finally analyzed at the application server. This brings me to the research specifications. UTS researchers have been studying low-cost wireless sensor networks in various locations around Sydney, and specifically for this project, the suburb of Melrose Park near a construction site. Now, what is a problem? In this research, I answer four problems. Firstly, cleaning and preparing the data collected. Secondly, is generating data visualization tools. Third is studying this data and understanding how local activities impact air quality. And finally, developing a conclusion to see whether this tech is feasible at measuring air quality. To validate low-cost census data, I have utilized publicly available environmental data provided by the Department of Planning, Industry and Environment. The location of the station is 4 kilometers away from the study site at North Parramatta and will be utilized as a reliable comparison to evaluate the LWSN. Next is cleaning the dataset. With LWSN, there is often network interference which affects the data, as we can see on the line graph on the screen, showing particle readings from the DPIE station indicated in the green line and the low-cost sensor in blue. We can see that there are two instances of missing data from the raw dataset. Situations such as the following can affect the statistics and provide viewers a false narrative about the air quality data of the area. The solution which I have developed is a data processing method. The pipeline begins with low-cost sensors sending data to the server, then the data processing stage taking place where the data is then transformed into a more reliable, presentable state. This is done using the data analytics platform called KNIME. Then finally, the values are presented in a visual graph for viewability that has insightful air quality information and is done using Tableau. The entire process is automated. The challenge I faced during this project can be split into three categories. The first is with analytics. Due to the lack of data gathered, I couldn't use machine learning to train the model as I initially hoped, and I would have used this to predict the missing values. Secondly was with the environmental analysis. I come from a software engineering background, and my knowledge on software and environmental science is quite limited. Therefore, I couldn't go into much detail as I hoped. And due to the bushfires which occurred in 2019, I was unable to see the differences that construction had on the air quality. Data visualization was another challenge, as I was unable to develop a visual tools because of the lack of data I had. After data processing, the raw data was successfully able to be transformed into a clean and presentable state unlike before. The technique which I used to manage the missing data was with a method called last observation carried forward. This works by using the previous non-zero value and carrying it over to where it is missing, as we can see in the line graph, by the blue line representing the raw data suddenly dropping. The prediction values, as shown in red, has removed this dip by flattening the curve. This is also supported by the statistics shown on the right-hand side of the screen, with zero values becoming non-existent in the predicted dataset. And finally, are low-cost environmental monitoring systems really feasible in smart cities? To understand this, I have compared the processed data with the data collected from the environmental weather station. Looking at the graph, we can see that the values are very closely related, with few discrepancies but is justifiable due to the distance between the two sensors. This is also supported by statistics shown on the screen, with both datasets showing very similar values, and an average value of 0.8 difference between the two. Innovation in this project is seen through the development of a data pipeline to process readings coming out of the low-cost sensor, understanding the benefits and weaknesses of the technology, and providing evidence to support LWSN technology for environmental monitoring in urban areas. The developed technology can be commercially utilized through scalability of low-cost sensors across suburbs to create a smarter city, the ability for the tech and data pipeline to be self-sufficient, requiring little maintenance once configured, hence cutting manual effort, and capacity to release live air quality data as soon as recorded. Potential customers who can benefit from this technology include the mining industry, being a huge contributing factor to the Australian GDP by almost 10% in 2020. They can benefit by having air quality data of their mines, thus affecting the health of their employees. Construction sites can similarly benefit from this project, such as Sydney Metro can find lots of information about the tech through the health and safety of their workers, about the air quality. And then finally, government agencies who can utilize this technology near motorways, urban roads, and public spaces. Invention was proven in this study through the development in data analytics field by creating of data pipelines that cater for LWSN data, specific data pre-processing methodology to cater for the environmental data, and with data visualization, automated graph creation using Tableau, and creation of weather dashboards. The future looks very bright for LWSN technology, and future applications include eventually replacing the need for environmental monitoring stations, which can cost thousands to set up and require an ongoing maintenance cost. More live data for the public about the air that they are breathing and how it affects them, especially for the community who suffer with breathing difficulties. The project can be continued in the future by further research into improving the prediction of accuracy, AI software to predict air quality on the next day, on air quality for the next day, for example, and developing a web platform to display the statistics for the public. From this project, I was able to apply my skills taught to me in software engineering to industry problems through the development of data analytics solutions specifically for this technology, thus further extending my research and development in smarter city technology to benefit society.